Yeah, my name is Keith Lynch. I work as an app dev specialist for Red Hat in the UK. I actually now manage a team of those kind of specialists. So my day job consists of kind of going around to Red Hat strategic clients, talking to them about what they're doing with Red Hat's technology and why we're important and where they're going in the next kind of 5 to 10 years. I talk to people from kind of CTO to office of CTO to architects to kind of lead technical people to developers and kind of everything in between and around. So kind of a lot of experience in this area. I also run our Microservices Day. So we do, anyone here been to the Red Hat Microservices Architecture Day? A couple of people, yeah. So I run that with Rob Davies and James Strachan. So we've been doing a lot of thinking around microservices and containers. And this talk is about why we think kind of containers are relevant in kind of microservices, what we're kind of doing, and you know, kind of from an agenda, I'll talk about containers as an abstraction for microservices, and then I'll talk a bit about what Red Hat are doing. I'm specifically not going to, this is not a pitch. I talked to the guys here about, you know, this is not a vendor presentation where we kind of go, you know, buy X and Y product from Red Hat, we're doing all this stuff. I'm just going to talk about what we're kind of doing in the community. I'm going to try and stay away from everything that's kind of Red Hat product. So this talk is more about the experiences that I've seen, why containers are relevant, and what people are doing and what it kind of means to the industry and what it means to people. So kind of, I think, you know, a lot of the speakers so far have talked around kind of microservices and what it brings, and I think Adrian, who's sitting down here, was talking about, you know, as you build out more and more microservices, you need to be able to deploy, and the whole automating the deployment mechanism. Previously, people used to be kind of, if you look at this kind of top line, they used to be, you know, in a data center, they had limited automation, and maybe one language, and everything was kind of waterfall. People are moving more towards kind of in the cloud, automated by default, and pick any language you want, and kind of more DevOps. I think software companies have been really good at kind of being down here. I was an engineer back in 2001, and we were using cruise control, and we were fully automated, and we were doing CI/CD. We were doing, like, you know, tear up, tear down infrastructure, and that was over 10 years ago, and it was with C++. It wasn't in the age of Docker and containers, but you know, this stuff is not new. I think software companies have been doing it for many years. I think financial services companies, I think governments, people who aren't necessarily software writers or software functions doing this at a kind of enterprise, you know, a non-software or independent software vendor enterprise, they've kind of been learning a lot of this stuff over the last couple of years, and it's becoming mainstream. So the classic problem is devs write apps, they chuck them over the wall to ops, and kind of what do ops see? Well, the devs see kind of this beautiful thing they've spent the last year or 18 months or 3 months creating. They think, this is my thing I've labored over it, this is really nice. And they hand it over to someone in the ops camp, and the ops guys, they just see garbage, right? This is just smelly. It's logging too much, it uses 32 gigs of RAM. What were these developers thinking? You know, they want to have, you know, a 16-core machine that you screw them. They're not going to get 2 cores. It maxes out. It's just it's a whole different ballgame, and the reason it is because, you know, one, you've got a process whereby previously people were running these kind of monoliths where it was taking maybe a year, 18 months. Some programs were multi-years, like they were 3, 4, 5 years long. I was on a big project, one of the first projects when I moved over to London here for a credit card company, and there were 150 people on the project. And I was there for 3 years, and we didn't release. And that was kind of painful. and then I was on holidays for about 2 years. I kind of took 2 years off. I took a break, and I traveled down to Africa on a motorbike. And when we were down there, I remember being about 2 years in and forgetting all about the project and kind of hearing from one of the guys that came back to London. We were having drinks. I was, "Are you guys live yet?" And he goes, yeah, this week we got it. And it's like 5 years later. That, you know, things take time, and this process is broken. I think microservices is a realization of that. But the fundamental difference is devs are creative. If you're in, you know, someone, you know, the speaker who was just on, Jason, was talking about innovation, and innovation doesn't start from the top. It very much starts in engineering teams. It starts from people who are building things, who are being creative, who are looking at business problems and kind of going, how will we solve this? How will we use technology to kind of address this? These people are creative. These people, they want stability, they want security, you still have to go to them. The operations team within any organization, any enterprise organization, has to have some level of security. And generally what this has bred is kind of centralized IT, having standards, having technology architecture boards where actually it's not kind of a technology architecture board that's open, it's one that's really closed, and you need everyone to vote, and you need a quorum of everyone to kind of say, we're going to use this technology. But the operations guys, they're there to maintain and make sure that the environment runs, it works, it's stable, it's patchable, and if there's any issues like Heartbleed or any bugs, they can kind of come in and fix that infrastructure. I think in many ways, like what's classically happened is people have talked, differently. For devs and operations people, it's just they talk a different language. They're not really talking the same thing. And as an effect, like the vision for the application and what you're developing and delivering, that kind of becomes compromised, which is not good, effectively. So enter containers. I think, so everyone's talking about Docker. I think there's nobody in this room who hasn't heard about Docker, but containers, one thing when I was kind of going through a lot of this stuff and over the last 2 years, containers are not really a new technology. You've got two things with containers. You've got container runtime and container packaging. And the big thing that Docker has brought us and what the guys in Docker saw was this container packaging format, because the container runtime, that's kind of a known thing. We had kind of SE Linux, C groups, LXC, Linux namespaces, runC, things like Creo. You also have things that Solaris owns, IBM had LPARs. So all that kind of runtime containing an operating system process on an operating system and making sure that it couldn't take 100% of the CPU of the box. If it was only given 20% of the CPU, that's all it would take. If it was only given 10% of the bandwidth, or if it was only given like a 256 up and a 1 meg down, it would only take that. So all of that resource constraining, that's kind of, we're good. We have that at the operating system level, and we've had it for a long time. The guys from Google who contributed C groups into the Linux kernel, that was done around 10 years ago, so it's pretty known technology. For people who don't know what containers are, this is kind of my base slide to tell people what a container is. So in a traditional world, you'd have the host OS, you'd install libraries, and you'd put your apps on the machine, and it ran on hardware. I don't think anyone does this anymore, but people do that on a kind of a virtualized hypervisor. The problem with this is if you change one of these shared libraries, you have to test application A and B. So you don't have that separation anymore. And the people in kind of the ops world, they can't have control. And you also can't do interesting things. So a lot of people that I've seen recently, when they build apps, they deliver them as virtual machines. You kind of have an app, and you have the libs, and you have the guest OS. Delivering software as an operating system image is kind of broken, right? That doesn't work. It's really slow. People are getting there with provisioners. I've seen a lot of people using Chef, Ansible, Salt, Puppet, and they do this stuff, and they've got it to a reasonable degree of automation. The engineering effort that they've got to do that is good, but it's slow. I was using Vagrant on a project about 2 years ago to build out something like this on my laptop, and I was building out the Vagrant scripts and for production before I was pushing them live, and to build up the whole prod environment using Vagrant on this laptop, it's a pretty beefy laptop, still took about 20-30 minutes. And you don't want to sit there and just press a button and wait for 20-30 minutes, like build time. And that's just deploy time. So containers is you take this concept, and what you do is you package the libraries and the application as one image. And then that image is kind of immutable. You pull it down. And if you want to change a library, you just change the library in that container for that application. And that's all you change. And then you can pack these guys onto the OS. And I think I'm going to talk a little bit about kind of efficiency, but you don't really need the hypervisor anymore. When Google were investing in this technology in C groups, they had so many data centers that to make a 15% saving at the hypervisor layer meant they could save hundreds of millions on kind of data center. But I think there's a lot more things I'll talk about later. But the big thing that's really changed, I think, is just the container packaging format. And there was, I think, in this space, I saw over the last 2 years, there was people going in different directions. So you had kind of the Rocket guys, the Docker guys. There's the AppC spec. I think the Open Container Initiative is definitely one to watch. Pretty much everyone has joined up to that. And the Open Container image specification for images is great. But this is really what's revolutionized everything. And this is the single currency that people can now kind of speak. So you can get rid of all of this kind of devs talk with one kind of packaging format, and operations talk with another. Just everybody talks containers. Devs build containers. You can build containers on your local machine. You can test an entire production environment on your local machine, and then you can just move that across. You don't have to rebuild all of your software for each promotion to a next environment. All you do is you've built the containers, they work. They're probably going to be an automated system, like you may have Jenkins, you may have Bamboo, and that will build out and test for you, and that will have kind of the go build once it's passed. But after that point, you don't push them anymore. That container is done. The dynamic that then changes between the operations and developers becomes one where you talk more about changes, incremental changes, as opposed to this whole big bang change. So this starts to enable some interesting things. So you go, okay, we'll agree on 3 or 4 kind of host-based images that we'll work with, maybe even just one. We'll agree on a certain amount of runtimes, and that could be a JDK. It could be something for C++ libraries. It could be a logging framework. And then you agree on next layers up on top of that. So I've taken, just to kind of demonstrate this out, so as a developer, I want to build an application, kind of like a web app on Tomcat, and I want to use Tomcat 8033. So what do I do? So the ops guys will go, we have a standard image, and yeah, they use Rel 7.1, so what? And the dev guy goes, okay, I'm going to use the Rel 7.1 base image to build an OpenJDK image, and that would be a layer that builds on top of the Rel layer. And then he suggests that to the ops guys. The ops guys kind of go, okay, have you got some tests for that? Maybe the dev goes, oh yeah, I've written some tests for this. There's something that goes and runs Java, gets the Java version, runs Java C, maybe compiles something. And then that gets improved, and it goes into this repository. And this repository is key, because having the repository where you can share artifacts between teams, not just dev and ops, but between other development teams in your organization, that's where this power comes and where it becomes really interesting, because ops can kind of go, we will approve layers at a layer-by-layer basis, and then we can build on them. So next he says, okay, I've got the JDK image. What I'm going to do is I'm going to build Tomcat 8033 and get that approved. Once that's in, already now you can have different dev teams going and building stuff on top of the OpenJDK image. So you might get somebody using, they could be using WebLogic, they could be using JBoss, they could be using DropWizard, it could be anything, Spring Boot. But that would all be built off that image, and kind of the ops guys know how that image works. They know how it ticks, and that contract's kind of there. After that, then the developer can actually go and do what they want to do. So I think when you start building up your layers, that the layers are going to be where there's a lot of interaction with the ops teams to get those things in. But once they're in the repository, they become really shareable artifacts, and you can have. There's not just going to be one repository. There's probably going to be one repository for sign-off operations, but there's also going to be repositories that you and your dev teams have for how you share the microservices that you are building between each other, and that becomes really, really interesting. So once something is in here and it's gone by the ops people and it's been tested for your application, pushing it out to a dev environment, QA, a prod, a UAT, that's just a Docker pull really, and I mean, the speed that this creates and how you can move, and it's just great. So it kind of enables that loosely coupled delivery, which I think is necessary in this kind of microservices world, because, on my next slide, what does this have to do with microservices? So I think, from our experience, a microservices basically ends up as a container. So each microservice, I liked your talk Adrian, when you're talking about how many lines of code. We've actually seen as well, like 2,000 to 4,000 lines of code are kind of your ideal kind of sweet spot with microservices. I tell anyone if they're going over 5,000 lines of code, it's too much to sit down. If you're a new person on a project and you've never used a piece of code before, anything over 5,000 lines of code is hard to digest. 1,000 to 2,000, you can sit down for a day and you can kind of go, I can figure that out. So each microservice would then be a Git repository. Git repository would have an image that would then be your Docker image, and then that's your microservice. Images and layers and all of that stuff basically become contracts between dev and ops, but will also become contracts between you and your other development team. So you may have let's say you and 2 other teams have a release you have to do. You can kind of release independently, and you can version at different points, but you can take what they've built and you can build stuff on it, and they have a new release. They can go, oh, we have a new release ready. we'll try and use it. No, it doesn't work. We'll wait and we'll do all our stuff on here, and we'll take it as tech debt, and we'll do that upgrade onto their next release at another point in time. So I think that stuff becomes really kind of easily manageable. The whole DevOps thing, so building once, kind of don't repeat yourself, don't build stuff many times. The cluster container orchestrators that build on top of this, things like data center operating systems like Kubernetes, they give you that ability once you've done this to do things like roll forward, roll back, auto scale, blue-green deployments, canaries, dark canaries. I think there is a lot of stuff around testing. I think don't fool yourself. That doesn't come for free. You still need a process on all this thing. So all of the things where you would have CI/CD processes, all of that stuff becomes really key, because unable to do it, in order to get to here and do this kind of stuff, you need to be doing a lot of this. Because if the ops guys want to patch your JDK, they need to be able to run all of your testing for your application or your microservice before they need to do that in an automated fashion so that they can roll that update out without contacting you or the app team who wrote that code. And that's critical, because without that, they won't be able to patch the 300 applications that are using the JDK that has that bug. The next level that builds on top of that is container orchestration. So obviously, Red Hat are investing in Kubernetes, but there's a ton of kind of technologies in this space. I think once you can only go so far with Docker before you have to start looking at things like Swarm, like Kubernetes, and those things become really important, because without those abstraction layers on top of just mere containers, there's no way to kind of weave the containers together to form an application that you don't get that roll back, roll forward, and you don't get things like auto scaling, things that a platform that can package and manage containers in a unified fashion can really bring to you. So what are kind of Red Hat doing? So we've been kind of staunchly kind of telling people and got them and convinced them to go with the Open Container Initiative, which is a Linux foundation. There was about a year and a half, 2 years ago, a real kind of risk within the industry of people separating and not getting around one container spec. So that's really good. We're also investing, obviously, Red Hat Enterprise Linux, we're traditionally an operating system company, so we're investing in all of the underlying technologies that kind of enable this from a kind of a runtime and a packaging perspective. Kubernetes, we're investing in heavily as well. We think it's a really interesting technology for doing all this stuff. And then recently, one of the things that I thought was really cool for Red Hat, coming from a development background, we've just made RHEL free for developers. So if you're a developer and you wanted to use RHEL, it used to be a pain. A lot of the dev teams that I go and talk to, they use CentOS. So now they can use RHEL for free, basically. So it's one of the interesting things that Red Hat are kind of acknowledging, that to support all of this and to support people building containers, we kind of have to give the operating system and make it free to developers for using. Other things we're doing, .NET Core on Linux, which I think is really a really interesting one. So a lot of customers I'm talking to, they're thinking about running kind of Microsoft workloads on kind of Linux platforms. That's interesting. Like writing a .NET app on a Mac, that's it's just mad. It blows my mind. And just it's kind of mad stuff. We're also investing in, like, one of the things traditionally with RHEL, I think used to aggravate a lot of people in the dev space. If you wanted to use Node or Mongo or PHP or Python, you'd only get the version that was in RHEL. And because Red Hat released that at like 5 and 7 year intervals, it doesn't rev very fast. So because of that, we've got software collections, which is kind of a quicker rev of all of these underlying technologies, and basically you can use kind of the latest and greatest in a kind of semi-supported fashion. So we only support those things for like 1 or 2 years once we release them. One of the things, this is probably the most important thing I want to talk about, which is kind of industry trends and what I'm seeing from the meetings that I'm in and the people I'm talking to. The biggest thing I'm seeing is actually just move to cloud. Everyone I'm talking to about containers are like, if we can get containers working in our own data center, we can just move this stuff to the cloud. Or if we can use containers in Amazon or Azure or Google or public cloud, it's going to be very easy for us just to consume that. And if public cloud doesn't work out for us, we can always bring it back in as well. So that's one of the most interesting conversations that spurns a lot of this and why people are thinking about containers above and beyond just microservices. move to cloud has actually become real. I know a lot of people talked about cloud as a big buzzword about 2 years ago, but it's suddenly becoming real for, I have 3 big financial services clients, and they're all moving to cloud at scale. It's kind of scary. Public sector as well are kind of doing this. I think there's a massive move away from centralized IT. People know that centralized IT is broken. People I'm talking to are just kind of, they're almost acknowledging that this command and control approach from centralized IT of thou shalt use this version of this, thou shalt use like this integration framework or product for all of your integration needs, that doesn't really work, and it doesn't really scale in an organization. Organizations are starting to really acknowledge that they took 3 years to evaluate and bring a technology in. In that time, shadow IT took off, and people just went and built their own stuff. They just went and they went out to a mobile company and bought a mobile app that they used to do things. They brought some contractors in to build stuff and maintain it for them. And there's a real acknowledgement that central IT have to empower lines of business and developers and people who are in engineering functions to innovate and not push innovation down, but enable innovation from the bottom and let people make their own choices around technologies. And that's actively happening, which is really good. I think agility comes into that. People do want to move faster. They don't want the 6-month, 1-year release cycles. And with this microservices stuff, if you're going to be deploying and managing more and more artifacts, you're going to go faster, and you're going to need to go faster, because unless you can release software really quickly, don't do microservices. Because if it takes you like a year to release one component, think of that times 100 components. You'll probably be dead and buried before your software gets released. It won't be a 5-year thing. So you need to fix the release process before you start going down this path, and looking at how you do that is I think key. I think so is dead. I think a lot of people, maybe that's a bold statement, but people thought that they could have one piece of software that could manage, let's say you take a big bank like JP Morgan, they have like 180,000 people. Could you put an application in there, this SOA bus that managed everything for JP Morgan? It was never going to work, right? How many teams are there inside that bank? So none of these banks, I just picked them as an example. They're not for any specific reason, but just because they're big. But if you take any bank like that, there's no way you could have, it's not scalable. 2 teams start using it, and already you've got, oh no, we don't want to release at Christmas because that's our thing. And people want to enable teams to go faster. And I think there is an acceptance that SOA is kind of dead. Microservices is kind of a re-envisaging of SOA for let teams do what they want. If they can share, give them the tools that enable them to share. I think having containers and container repositories that teams share across each other, and having kind of teams of people whose job it is to look across and see where people are sharing, where there's the possibility for maybe people are doing duplication. I think that becomes a job in and of itself. So kind of like this architectural board who have a lot of influence but maybe don't make the decisions or don't have the final decision. I think it's their jobs to kind of look at what people are doing, survey the estate, and survey everything that's kind of going on, and look in and kind of go, well, you guys are doing the same thing. Why don't you use the same component? And then they kind of go, oh yeah, that would be a really good idea. I didn't know that Joe was creating like a new network protocol or whatever. I think the infrastructure efficiency thing, that comes up time and time and time again. One of the large banks we're talking to about this, they have their own. They basically created their own paths a number of years ago, and they're using C groups and the kind of the container runtime technologies. And they have 20% of the bank's apps on 3% of their estate. That's phenomenal. Like, if you think, then the rest of the estate, 80% of the apps use 93%. So they want to move to having 80 to 85% of their apps. And you can think they'll probably bring that infrastructure saving down to maybe 16 or 20% of their current estate. They can switch off, and like they're massive. They're another kind of 200,000 people type organization. If they can cut 80% of their infrastructure costs off, they can bring that in and start enabling people to do more interesting things, like answer kind of business requirements and build stuff in the market, and not be caught by people like Square or Apple who are kind of eating their lunch. I think I think there's a talk later who's who's talking on kind of containers and operating system and virtualization, but the whole efficiency thing. I think there's people talk about just the going from a virtual machine to a container and that will make you faster. There's that, but there's a lot of other things besides that. So it will make, it will make you be able to put more stuff on the box. You can release faster. Releasing faster is going to save you way more money than just the 15% in CPU cycles that you may lose because of virtualization. That is if you can make that saving across the entire organization, that's just a massive saving. That's about it. Any questions? Awesome.